Nowadays, autonomous underwater vehicles, AUVs, have become the vehicles of choice in many surveys. Towed systems, however, still have some advantages. Let us look at them in 2.5 minutes. Because the power is provided externally and there's no real size constraint on the towfish itself, it can carry really powerful side-scan sonars. Yeah, these can be provided on AUVs as well, but only those big enough to accommodate them, and these tend to be far more expensive. Shipboard power also allows survey operations to continue for hours and days at a time, and unlike AUVs, towfish have no batteries to recharge. The ship motors are also located quite a way away from the sensor, and this reduces the potential for noise to contaminate the sensor readings. Conversely, AUVs have all sorts of inherent noise sources from the motor, DVLs, USBLs, multi-beams, acoustic modems, all located in close proximity. Yeah, if the system's been integrated properly, then these noises shouldn't interfere with the sonar images, but this isn't always the case. Another feature of towed systems is they provide real-time data. Now this is really important. In comparison, AUV operators have to wait for hours to retrieve and download the data. Real-time information is advantageous for many reasons. For example, it's useful to optimise the sonar settings at an early stage in the procedure. Operationally, getting real-time information from a side scan, for example, means operators identifying a target can go back over a zone of interest immediately, maybe from a different angle or with a higher frequency setting to verify it. One historical issue with AUVs is there's always a fear that they get lost. A battery dies, physically gets stuck, or can't be retrieved, communications are lost. The risk influences the operational planning decisions concerning how and where the system should be deployed. Operators of towed systems, however, have the security of knowing the vehicle's always at the end of the cable. Towed systems can often be deployed and retrieved with far greater ease than AUVs. They don't need a knowledgeable AUV operator to operate it, and as such is suitable for work in areas of the world where the skill pool doesn't offer this facility. Historically, AUVs have gained a lot of traction from exploiting the argument that towed vehicles were literally tied to the survey vessel at the surface. They couldn't be programmed to go off and carry out surveys automatically. Well, of course, AUVs also require vessel support, but like all industries since the Industrial Revolution, one way of driving down costs is by introducing automation. And this is perfect for AUVs, but an avenue not open for any vehicle dependent on its mother vessel that controlled and power the entire operation. In recent years, however, this has changed with the advent of autonomous surface vessels, ASVs. In many ways, towed sensors could often outperform sensors on AUVs, but weren't able to live with the other advantages that AUV brought. Well, by bringing autonomy to the support vessel rather than the underwater vehicle, it sort of changed the market. One company has used a side scan under its USV, that's unmanned surface vessel, while another completed the first ever seabed cable route survey supported by USV, and this survey route included various water depths and currents and facing difficult wind conditions and sea conditions in the Bering Strait offshore Alaska. Towfish have also been towed by AUVs and also surface wave gliders. Yes, AUVs have lots of advantages over towed systems as well, and we'll look at those later. There's room for both systems in the market. If you want to know more about subsea engineering, read UT2 or UT3, the print or online magazine of the Society for Underwater Technology.